In this video, we are going to talk about the key characteristics of the polynomial functions related to the rate of change. So what is a polynomial function? Polynomial function has more than one degree, one or more than terms, and this is the leading term, which is a n x to the n. And we always write in a descending order. So this is the highest degree, and this is a constant. So what's the degree of this polynomial is called n, and the leading coefficient is always called an. So let's practice with a couple of examples here given. Find the leading coefficient and the degree of the polynomial function. So this is the highest degree. So that's why we call this a leading term, and the coefficient is a 3, degree is a 4. Sometimes they trick you by not putting the terms in order. So search for the highest exponent, which is x to the third. So the leading coefficient is a -7 and degree is a 3. Now this is a constant term, so you can say x to the 0. So coefficient is a 4 and degree is a 0. All the constant terms are called 0 degree. First degree is a linear function, second degree is a quadratic, so this 0 degree is a constant. Now let's talk about the extrema. The extrema of a graph are maximum or minimum of the function, and there are two types of extrema. So you are supposed to find out the x value as well as the y value. So first of all, let's talk about relative, which is also same as local. But the relative is a more common word than the local. Absolute is the same as a global, but we use most of the time the word absolute. So what is a relative max or mean? Relative max or mean could happen anywhere relative to the other values in the graph, where graph switches between decreasing to increasing or increasing to decreasing. And the most important sentence is here, at the end point if it has a restricted domain, which means if there is a dot here, not arrow. So giving this example, look at this example, there is an arrow here in case if you did not notice that. So what's the restricted domain? There is nothing here. So the restricted domain is -4 and onwards. Now, where is the relative maximum and minimum? So minimum means lowest number here. There are two relative minimums, but at, which means x values. So you have to look at the x values at -4 and 0. Minimum means you are looking at the y values, but you are writing at means location of the x coordinate, where maximum is this 2, which is -2 and 3. So what is the absolute now? Let's talk about the absolute. Absolute means greatest of all the maximum and least of all the minimums. And always absolute is check the range. So here is this is the same graph. So you can see it's going forever down. So if I look at the range, this is my maximum value. There is nothing above. Arrow is pointing down means it goes to -infinity, which means absolute y value of maximum is 2, where at 3. Absolute minimum, if the graph is going to forever down to -infinity, which means there is no absolute minimum, none, not applicable. So one more time, there are two minimums and two maximums. Out of these two maximum, which is the most, is absolute. Out of these two minimums, but then there is a keep going forever, so that's why there is no absolute minimum. So let's take a look at one more example. Find and classify each type of extremas. So check first of all arrows. Arrows going down, that means it goes to negative infinity, which means there is no absolute minimum. There is only one, which is relative or absolute. There are no relative minimum also. There is no valley. Minimum means you are looking at the valleys. There is no valley. There is only mountain here. So relative maximum at x equal to 1. Relative is the same as absolute. X equal to 1. They both are same. Now absolute maximum value. Value means y value, which is 3. Understand how to read the graph. Both end arrows means goes forever to negative infinity, which means range is negative infinity to 3, and that's a 3 is the maximum value. Let's practice a couple of more examples here. So first of all, check the dot and the arrow. Arrow means goes to negative infinity, which means it does not have any minimum. Does not have any minimum. Okay, then this is a relative minimum, which is at x equal to negative 2. Relative maximum, we have two maximums. One is at negative 4, another is at 3. Negative 4 and 3. Now, out of these two maximum, which is the most one? This one or that? So clearly you can see that's the most. So value is a 2 at x equal to 3. Practice. Let's check it out. One more. Both are close ends. So it has everything, maximum and minimum. So look at the range. The lowest number is negative 3, which is absolute minimum is negative 3 at x equal to negative 3. This is the value. Value absolute max is at 4. Sorry, value is 4 at x equal to 5. Okay, so we figure out absolute first. Now let's talk about the relative. So clearly we have a two relative minimums, negative 3 and 3. And maximums, we have a 1, 2, and 3, which is at negative 4, 0, and 5. So 2 minimum, 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 max, max, max. So each of them we identify, and we identify absolute. Now, fun facts about polynomials. It's a common sense part, not really a facts, but we later on we will put this as a theorem in calculus that between two real zeros of polynomial there must be at least one local or relative maximum or relative minimum. So you don't have to memorize, and let's talk about this is why. So if I have two zeros, then I have two possibilities. Either and the function has to be continuous. All polynomials are continuous functions and the domain is all real numbers. So which means if I go up and then I have to come down, that means there has to be maximum. Or if I have two zeros, if I go down, I have to go up. That means there must be a maximum or minimum. At least one. At least one. It's also possible that you go up and down and then come down. So there is 1, 2, 3, 4, 5 relative extrema. But between two zeros, there is at least one. Okay, so the polynomial of even degrees must have either absolute max or absolute minimum. Again, this is, I would say, the common sense part, because all the even degree functions are always either goes up or goes down. So there must be maximum or minimum, and it has to be absolute. Again, because the range is playing the role for the even degrees. Even degrees, range is always playing part, either all on one side or all on the other side. So it's a fun fact. It's if you pay little attention to this part, you can easily eliminate certain choices in the multiple choice questions. So let's talk about point of inflection. This is very important part of the video. So make sure you pause or watch again if you need to. Point of inflection acronym is POI. We use that in calculus also. So point of inflection occurs when function changes from concave up to concave down or concave down to concave up. In other words, changes concavity. It changes concavity. So to better understand point of inflection, we are going to look at this graph. And we are going to check. So does this look concave up? Then this is concave up. And let me use a highlighter. This is concave down. This is concave up, concave up. So we can see the concavity. Now, what is a point of inflection? Point of inflection is where concavity changes sign. Point of inflection is always the x values. What values of x? So you can say x equal to -1 and 1. That's where the concavity changes from up to down, down to up. Now we have to understand the rate of change. So let's a quick review from the previous section, rate of change. Rate of change and the change in rate of change tell us about the function. If the function is concave up, rate of change is increasing. Function is concave down, rate of change is decreasing. So it's either way, the both ways. If the rate of change is negative, decreasing, then it's concave down. Now remember, we are not talking about the function, we are talking about the slopes. We are going to talk about the slopes. We are going to talk about the slopes, which is a rate. Okay, so now we have to look at the four intervals here. Between -3 and 4. So I'm going to bring my concavity thing back. This is concave up and this is concave down, so that we can write the answer. Okay, so between 3 and 4. Let's read the question back carefully. For each of the following intervals, determine rate is increasing or decreasing. Explain your reasoning using the feature of the graph. So between 3 and 4. Between 3 and 4. Between 3 and 4. What do you see about the concavity of the graph? You can see that the graph is concave up. If the function is concave up, which means rate of g is increasing. Explain the reasoning, because you can say g of x is cc up on the interval 3 to 4. You don't have to write it so much. We just have to look at the concavity. Rate of g is increasing because function is concave up. If it is concave up, it is increasing. One more time, I'm going to bring down this. You can check it out. Concave up, rate is increasing. Concave down, rate is decreasing. Okay, so between negative 4 and negative 3. Between negative 4 and negative 3. Again, concave up. So I would write rate of G is increasing. G of x is CC up. CC up is very popular acronym. You can use that. Okay, so now what is between negative 1 and 1? So negative 1 and 1, you can see concave down. Concave down means rate of G is decreasing. Why? Because G of x is CC down on the interval negative 1 and 1. Okay, so what's happening between 1 and 2? 1 and 2, you can clearly see is CC up. CC up, which means increasing, not the function, rate. So rate of G is increasing as G of x is CC up. So one more time, this is the only place it's decreasing because concave down. Everywhere else is CC up because G is increasing. So you have to answer all these questions based on the graph. POI is negative 1 and 1, and you have to identify rate is increasing, decreasing, and you have to tie it with the concavity. Now the last example 4, I do not have a calculator at this time, and we will do it some other time. Thank you so much.